Galileo, be a good sport and pass me that apple.
In the mouth, mate.
So Newton, you're looking good today. What have you been up to?
Well, I was looking through my drawers and I found some new laws.
Oh, can you show me what you mean?
Well, yes, I have these handsome young men who have had a perfect demonstration.
Newton's first law states that an object in motion will remain in motion unless acted upon by a resultant force. This will be shown by our frictionless slider.
Try again.
In the first instance, there's friction between the block and the table, which causes a resultant force, making this decelerate and slow down. In this instance, there is no friction between the block and the table, meaning that it does not slow down.
Whoosh. Hi. In Newton's second law, it states that for a constant mass, the force on an object is directly proportional to its acceleration, as shown by the skateboard trick.
This is with a small pulling force of 75 newtons. Give him a tug. This is with a greater pulling force of 150 newtons. Newton's third law states that if object A exerts a force on object B exerts an equal and opposite force on object A. This will be shown by bouncing this ball off the ground.
Try again.
Thanks, mate.
In this case, object A is the ball and object B is the ground, and the equal and opposite force is shown by the ball compressing off the ground as it bounces.
Cheers, Newton. So, Galileo, I hear you've been getting up to no good in Pisa.
Well, the Scooby-Doo-Bob-a-Doo-Boop, the Scooby-Doo-Bob, the Scooby-Doo-Bob-a-Doo.
Okay.
Well, let's find out more about that.
54, 55, 56, 57.
Oh man, that was a proper quick time. How are you feeling?
Oh god, I need a drink. That PE exam was harder than I thought. I'm gonna have to ring my friend.
Hey Josh.
You need to get me some water somehow. There's no water down here. You're gonna have to throw me some water down.
Alright, I'll get
me some water down here.
I'll get it to you really quickly.
Cool.
Look, there he is, just out the window. He looks like he needs a drink. So, we've got two bottles. Which one's going to fall quicker?
Well, obviously the heavier one. We're gonna have to give that one to him quickly.
You think?
Yeah.
Well, let's see.
Let's
you
try
do
it out.
that window, I'll do this window.
I don't have time. I need water.
Here we go. Go.
Here they are.
So which one hit the ground first? Was it the heavier one?
No, they both hit the ground at the same time.
Why is that?
Because as
Exam tip.
Galileo found out, two objects of different masses will fall to the ground at the same rate due to gravity.
Exam tip.
The difficulty with this experiment is that it's hard to measure two objects falling at the same time because people release them at different times. Nowadays, multi-flash cameras are used.
Well, another theory I came up with was momentum. It's Skinner. Well, here it is anyway.
This ball is a light ball. It's made of feathers and cotton wool. Let's see how it acts on Alex. This ball is a heavy ball. It's made of lead. Let's see what it does.
Right, cheers for that, boys. I think I've learned a lot today.
You're very welcome, young boy. This has been Science with Galileo and Newton. It's good to bomb it with a
Three. Lewis, shut up!
In the first instance. In the first instance.
George.
Get all good.
In the first instance, there's friction between the block and the table. 4:53.
That's what I needed.
So which one hit the ground first? Was it the heavy one?
No, they both hit at the same time.
Why is that?
Because everything
Exam tip!
hits the ground at the same rate. Because gravity
It's filming.
locks your cheeks, Alex.
Do another one.
Mint.
Trying to aim for the face more. So Newton, you're looking good today. What have you been up to?
Well, I was looking through my drawers and I found some new laws.
The difficulty with Lewis. So Newton, you're looking good today. What have you been up to?
Well, I was looking through my drawers and I found some new laws.
Cool.
So Galileo, I hear you've been getting up to no good in Pisa.
Well, it's good to be able to move. It's good to be able to move.